Hello guys, hope you are doing fine. Okay, so this is our first video with a voiceover. I hope you will like it. Stay connected with this video at the end so that your basic concepts about FEA will be cleared. Like as an FEA engineer, you would come across some kind of these kind of problems that you have to finalize which design is best suitable for your operation. As per the name suggests of this video, we will try to simulate a flat plate using Ansys. We will model that plate in Solidworks. Personally, I like using Solidworks for modeling. Like it's a very good software and easy for learning. You can find very much tutorials if you are a beginner in Solidworks. I will try to cover other modeling softwares such as CATIA, Inventor, all these things, but I will consider that in upcoming videos, right? Okay, so first I will give you the brief overview about what we are going to do in this video. First of all, we will model a simple plate using SolidWorks, and then we will import that geometry to Ansys, and we will simulate the problem. Like for example, you have as you can see, this is a simple plate which will be having a hole, and in this analysis we are going to fix this side and apply certain load, and then we will see what kind of a total deformation strains and stresses are generated throughout the cross section of that plate. Okay, so now I will switch to SolidWorks for modeling of a plate with a single hole. Okay, so we are now in the SolidWorks tab. So what you can do, you can create a new part by clicking OK, right? Okay, so now first of all we will sketch the geometry. We will click on the sketch, and then we will do sketch on our top plane, right? We will select the top plane. Now you can take a center rectangle from here and click anywhere here, right? Okay, so the dimension of this would be 100 by 100. So we'll go to smart dimension, and then we'll dimension this side as 100. Okay, and this side will be 100 as well. Now we will draw a hole. This will be around 30 total 30 diameter, right? Okay, now we will go to features, and then we will extrude our plate. We will select a mid plane from this, and we will apply 5 mm thickness in both the sides. Okay, so plate will look like this. This is the first scenario which we are going to use. Like now you can save this file as per your convenience, where you want to save in your directory. Okay, so I will save it as one plate with round hole, right? Okay, you can save it. Now for the second case, what we will do, we'll edit the sketch, we'll normal to, and we'll delete this circle. Okay, now we'll again go to the center rectangle, right? And then we'll do something like this. Okay, the center square hole will be 30 by 30. So we'll go to smart dimension, and then we'll click on this line and make it 30. Okay, and we'll make it 30 at horizontal line as well. Okay, now you can simply exit. Now you have a plate with a square hole. Now what you can do is you can save this file as, right, I'll write 2 number plate with hole, right? Okay, and you can save it. Okay, and save, right? By this way you can model all the 4 plates we are going to. I will give you the quick dimensions of that plate. You can see this is our first case plate with a round hole, in which 100 by 100 mm plate, and at a center there is a hole of a 30 diameter. This is a plate with a square hole, same dimension, 30 by 30 hole. In this third section you can try, this is a very simple geometry, it is not very much complex, so you can model it using Solidworks, right? Now in this 30 by 30, and we have applied a 5 mm of fillet here, right? And in fourth case we are going to use a triangular hole, right? Okay, now we will import the geometry to Ansys for FEA and its calculation. Okay, so now we are in Ansys Workbench module, right? Now we will open a deck called as static structure, right? Okay, for engineering data we are going to use a default material called as structural steel. We are not going to change anything in materials. In future videos we will play with the different materials, but for this video we will stick to only structural steel. Okay, now I will import the geometry. Okay, so you can import the geometry by right clicking in geometry, import geometry, and place with round hole, right? Now we'll go to Ansys mechanical window. Our geometry is completely imported, right? As you can see, the geometry is fully okay. As an FEA engineer, you should first check the condition of a geometry before setting up it for analysis. This is a best practice, and you should always do that, right? Okay, so what we'll do, we'll try to mesh. We'll insert a method for this whole geometry. We'll use the whole body filter. As you can see, there are several filters are given here, so you can use body filter, and there are some shortcuts as well. Okay, we will select OK, apply. Okay, now we will go to hex dominant mesh. Okay, and insert a sizing of we will give, there is a, okay, we can, the default sizing will be 7.0, but we will need to make a mesh a bit finer, so that's why we will keep it 3 mm. Okay, now click on generate mesh. Okay, mesh looks quite good, and it's finer as well. Okay, now we'll proceed for another operation. We'll go to static structure and right click and insert a fixed support. we will fix this side. Okay, and we will apply certain load. We will go for force and in this section. Okay, so now I would like to add a force in X direction in positive. So we will go to, first of all we will apply the geometry selection, and we will go to vector and go to components. Right now in X components we will give 1000 Newton in positive direction. Right, this is the simplest ever problem, but the comparison will give you a brief understanding of how an FES software is working, and how you can get a result and compare all the results and then finalize your design. Right, we will look forward for total deformation, we will see for equivalent strain, and we will look for equivalent stresses. Okay, now we'll hit solve. This is a very simple problem, so it won't take much time for solving, but if you have a bigger geometry and finer mesh, then it will take a bit more time than usual, then you have to, but this is the main thing as an FEA engineer, like you will set up model in quick minutes, but then you have to wait for solver to respond. But it's quite fun doing these kind of things. Okay, so solver has completed the solution. Now we will go for total deformation check. Okay, so as you can see, at this side there is a zero deformation, say no deformation, and at this section, if you want to check minimum or maximum, you can check as well. You can go to results and maximum and minimum. As you can see, there is a minimum deformation here and maximum deformation is here. Like similarly, you can do for all the four cases, like with simple hole, square hole, filleted hole, and a triangle. You can try by your own. Basic steps: you have to fix this side, and then you have to apply force of this side. Okay, so for the time being, I'm not going to simulate all the models. I already have done all the simulation for all the models, so I'll quickly show you the results we have obtained. As you can see, there is a total deformation. If you want to animate it, you can see this is how a plate will behave. Equivalent stress, most of the stress is in this section, so if we apply more load, then the plate can break from here itself. Right, okay, so now we will check for 3 other cases as well. Okay, so guys, as I told, I simulated all the 4 cases, and now we will discuss one case first, one by one. Right, in this case there is a deformation here at 0, and there is a deformation like 0.038 in mm. Equivalent stress is generated in this region. We will switch on minimum and maximum. Right, you can try using a probe if you want to see certain value at a certain point. Right, okay, we'll stop the probe. Okay. Now for the second case, plate with a square hole. Right, same boundary condition will be applied, fixed on this side and apply force on this side. For the mesh, same procedure, x dominant mesh and goes deciding of 3m. Okay, so now we'll see the total deformation values, right? The total deformation, as usual, it is 0 as it is fixed, and 00,15093 in this area, right? Okay, and let's check for the stress. Stress is generated here in the section, so we can say that the failure may occur, or failure or crack propagation will start from this section and this section as well. If we'll keep on increasing the load, the failure of a plate will be like this. Okay, so stress values 6.234 maximum in this region. Okay, in the third case, plate with a square fillet hole. Actually we had a hole of 30 by 30, but what we have done is applied a fillet of 5 mm. Actually, as we have seen that we are having a high stress region in this sharp corner. Okay, so let's see how it behaves when we apply fillet. Okay, the total deformation is quietly similar to in all the cases, 0 at this and 0.0014 in this region. Okay, but as you can see, the equivalent stress values in this region were 6.2, and in this section the area is, there is a small change, right, as you can see. Okay, and for the fourth case, triangle, let's see the deformation. Deformation is 1235 mm. This deformation is quite negligible, right? Equivalent stress, as these are the sharp corners, so there is going to be more stress in this region. That's why the stress is maximum in this fourth case. Okay, now I have made an Excel sheet for all the 4 cases and summed up all the data in one Excel sheet. So in first case we had a deformation as 0 and maximum deformation is 00130. Okay, the strain values are like this, 4 times 0358 mm, and the maximum stress is 7.1753. okay, for all the 4 cases. In the second case we have a maximum stress at 6.23 and deflection is 0.3, 0.4 times 033. This is quite very small and negligible, right? In the third case, the stress value gets higher, and this is the value for elastic strain, and the total deformation is 148. Then in fourth case there is the less total deformation, but the strain is higher and stress is very much higher. So if we want to okay, so we will sum up this. Okay, so in plate with a round hole, the deformation is 130. That is very low. With that, strain values are in range, and the stress value is like it's very good, quite near to the average. So this case is best suitable. Okay, so after consigning all this data in one Excel sheet, the question still remains: which design is best to force. Which design is best to force? So we had 4 simple plates with different types of holes. In first there was a round hole, in second one there was a square hole, in third one square hole with a fillet, and fourth one triangle. We applied same boundary condition, fixed this side of all this, and applied 100,000 Newton of a force in this direction. Okay, so this is the answer of our comparison video. Yes, this is the best design and this is going to be worse, and these two will stay in between, in that this is going to be average and this is moderate. Why so? Because there were sharp edges which can make the part fail. Okay, so there was fillet which will reduce the stress concentration, but not as burst as this. So this was the end of our video tutorial. So guys, this was my first ever video tutorial with a voice note. At the end, I would like to say one quote for all the learners of my channels. You don't have to be great to start, but you have to start to be great. I think most of the guys are new to Ansys and want to learn all those things and FEA concepts. So we will try to give you all the briefing about Ansys and FEA and Solidworks, all the related queries, and we will teach you all the things about how you can be best FEA engineer. If you have any kind of queries and questions, and then you can write us to rootxca@gmail.com. If you like this video, please comment how do you liked, and if you have any kind of suggestions, please let us know in the chat box. Thank you so much.